Okay, I guess I can start in a minute.
Yes, thanks, Alex. Just will you
Yes.
be doing the introductions across the other folks? I'm just not sure. I just want to make sure that.
Uh, I just said to Gora, I would love to take on more, but my children are sick and very,
Oh, I'm sorry to hear
very
that.
needy.
Okay,
Yeah.
okay,
That's why I'm a little bit
no problem.
challenged to carve out too much time budget. Yeah.
Okay, no
Okay,
problem.
but I better get started, I
Sure
guess.
thing. Sounds good.
And
Thanks, Alex.
yes, thank you so much. And then I better go here with the slides to the beginning. Yes. Okay, so welcome to the presentation, and the main person for this talk today did work with my former master student, who's actually also in the chat, and her husband Richard Trailing. So they're looking after their wonderful children. Also, in case I say something inappropriate, then Alina can always jump in and correct me. Yes, the title of the talk is exploring the potential really of smart contracts in pharmaceutical supply chains of Belarus. And maybe about the background, we had to pick some use case. It was in this case Belarus, because Alina actually comes from there. Okay. Yeah, so what are the challenges in the pharmaceutical supply chain? We have adverse events during transportation. So understand pharmaceutical supply chains can be very critical to transport, shouldn't experience too much shock, temperature differences, and so on. There's certainly a problem with counterfeit products. Since the supply chain is very complex and full of control steps and so on, it's very easy with all the parties involved to have disputes arise during among multiple stakeholders. And this has economical and reputational consequences of supply chain failures that could even render some pharmaceutical supply as useless. In the end, this may then lead, if the product in the pharmaceutical product is defect, to human health issues and lives being at stake. So, as I said before, my former master student, Alina, who's in the call, she looked at the case of Belarus and maybe historically at the time. We had the curious situation that Belarus opened up to blockchain economy quite a lot. It's gone a little bit quiet, but for a while in 2017, there was quite a buzz. A decree came out by the president of the Republic of Belarus on the development of digital economy. So what I recall reading on Cointelegraph and so on, they wanted to create opportunities, pretty much tax-free and so on, if I remember correctly, pushing a blockchain industry establishment in the country. So in that sense, we have then a definition of a smart contract probably taken from this decree, that the smart contract is a program code intended for functioning in a transaction block ledger or blockchain, another distributed information system for purposes of automated performance and or execution of transactions or performance of other legally significant actions. And we thought this would lend itself actually for application in pharmaceutical supply chains. So I can say here that we did this all in a master thesis exercise using case study-based research as a methodology. And for that, we collected the data from the producers, the carriers, and pharmacy chains in the country. So As the interviews were conducted, so in case study based research, you typically there's a chat, but now I don't see the chat window popping up. I don't know why. Maybe I see it here. Okay, never mind. For some reason, I do not see the chat, but in any case, we get to the chats later. So what are the challenges in case study based research? As part of that methodology, you conduct elaborate interviews with free flowing answers of the interviewees, which you then transcribe and analyze and so on, and conduct what is called thematic analysis. So what we discovered there was the biggest challenges are potential errors in the documentation. You have many parties involved, many different documents. There's marketing authorization, there's specification documents, shipment documents, registration certificates, all sorts of compliance documents, and on and on. I think in the next slide, actually, there is an overview, I believe, of all the documents which you get in a supply chain, pharmaceutical supply chain. So it's very elaborate, and you can understand that each one of these documents actually involves a number of different parties. So it's very elaborate. Given all of this complexity, all these parties involved, things can go wrong, and that can lead to all sorts of hiccups during the supply chain, yielding quality defects. Certainly, given compliance requirements. There can be wrong types of packages that might lead maybe to damage of the product. Poor quality of the production itself, non-maintaining cold chains. So in particular, I remember that these COVID injections were supposed to be very cooled, something which was then magically dropped later on. Why, I don't know. But in any case, cooling can be a criterion. And then you have climate control systems that may fail, and on. So it's a very involving endeavor to ship pharmaceuticals. And we then realized, studying how smart contracts can be used, certainly in combination with sensors, say with IoT systems guiding a supply chain. Smart contracts can then be used to enforce a temperature regime where certain thresholds are never breached on the upper side or the lower side if needed. Very interesting is also that you could have automatic payment systems, say in cryptocurrency even, which is much more feasible than, I would say, fiat currency. And also, given that this situation of pharmaceutical supply chain is very prone to conflicts, because of the large amount of parties involved, smart contracts may be used for, say, the governance to immediately impose fines and penalty payments. So as an extension, and given the keynote we just had before this talk, which was very good, it was mentioned that DAOs actually are very promising. So I would actually put forward the thoughts that even DAOs for governance and conflict management and resolution, say, dishing out fines and penalty payments would be very intriguing to use. So what are the biggest obstacles for the application of smart contracts? We think certainly the human factor is a very big one. Well, humans have run these supply chains for many years. They have a vested interest to get the salaries out of it. There's a massive innovation that completely turns supply chain technicalities upside down. So of course that meets a lot of resistance. Humans would need a lot of extra education. Many would probably end up being laid off, redundant. There are too many also participants involved, as we've seen before, not just individuals, but organizations. So this is a very conflict-prone scenario. The question is, can we eliminate some of the middlemen? So smart contracts or blockchains as such are known for being good to disintermediate, which is a fancy word for cutting out some middlemen that are suddenly then not needed anymore. Again, these middlemen, of course, they don't want to be cut out because their livelihoods depend on being part of the supply chain. So of course, again, a lot of resistance, bureaucracy, public level bureaucracy is always a source of resistance. Again, humans involved who don't want to change. And then we have costs. Probably initially we face costs, with the introduction of smart contracts, all the retraining and so on, the transition switching costs, you could say. Probably down the road, it's certain to say costs would actually be saved, but initially you would have maybe higher costs. So for future work, it will be interesting to study the influence of implementing smart contracts in the labor market in the pharmaceutical industry. Study also the impact of adopting smart contracts in one industry to the possible adoption in some other industries. So if you solve supply chain, say, automation with smart contracts, cutting a lot of time, costs, improving quality, and so on, improving the governance, the lessons learned would probably also work very nicely for other critical domains. Could study how to adopt smart contracts in one country. So this may influence the usage in the region, so not just in, say, in this case, Belarus, but also many neighboring countries. So there could be a spillover effect because also pharmaceuticals are not just produced and shipped around in one country. We could also study how smart contracts influence various market actors. So depending on the size of the company and on the form of ownership. And that's the first presentation. Thank you so much. And let's see if there are any questions. So I would maybe, if I stop sharing the screen, then I could actually see the questions here. Automate, okay. Okay. So sorry for switching, because I will also be the presenter of this one paper about the adoption of blockchain technology in academic certificate verification systems. So no harm done. This comes immediately after this presentation. I just switched them both now because I'm in both cases the presenter. Well done on the presentation. You mentioned automatic payments. We also had a project involving automatic payment using blockchain. Did you manage to execute automatic payments? No, we didn't. So again, this was case study based research where we interviewed people, not design science research. In design science research, we would come up with a proof of concept prototype. I would consider that also to be future work. To implement a corresponding system. In case study-based research, you're really trying to find out, let's say, in a nutshell, what are the requirements to change a not optimum as is state to a much better to be state. Oh yeah, and it says here, thanks, professor. I'm a recovering professor, so I used to be one, but not anymore. Any further questions? Okay, very good. in that case, I could actually even switch over to the next presentation, since this was already mentioned. Alena, do you have still something to add? We still got a minute.
No, all good. Thank you very much.
So I didn't mess up your story too much.
No.
Okay, very good. Then I will switch over to the other presentation, which was actually supposed to be the first one. So, okay. Right. Can you see this? Oh, do I still have to? I think I have to share the screen again. Where's my Zoom? Okay. Okay, I will share the screen again. Right. I hope you can see the screen. Okay, the silence probably means yes. Okay, then I'll switch to the slideshow. Right. Okay, so the second presentation, and my apologies again for the switch. This was supposed to be the first one, but the second one I presented first. So this is also work I conducted with my dear colleagues. Mercy Effiong, I think she's not present today. Let's just see who's present. So Mercy was also my master student once upon a time at Caltech. And Chibusur Utoko was my former PhD student, now Dr. Chibusur Utoko actually, and Marie Harting is an associate professor from the University of Pretoria. So we are an all-African authors team here, because I'm myself South African. And yes, so maybe, so now we're delving into a problem which maybe in first world countries is not perceived to be one, which is acquiring academic certificates that are actually, that you can trust, yeah? So that are verified and that you acquire in a timely manner. Just maybe as a little background story before I jump into this. And that's also certainly a problem in, say, Africa or developing countries in general. I traveled for 4 years on and off to Afghanistan, helping to set up the first master's program for informatics at the University of Kabul. And so I engaged with many Afghans, and they told me, if they have to apply for jobs, certainly also if they leave the country and they want to show to their potential employers academic certificates, it can take forever to acquire them. Certainly when you're out of the country, can at times take so long that the opportunity to get a job ceases to exist. So this was the motivation. And once again, this was also research conducted using case study-based research. So what's the purpose? We're trying to explore the current verification systems, academic verification systems, and the factors that undermine the effectiveness, efficiency, and convenience. We believe that blockchain technology can enhance the current verification processes for acquiring academic certificates. And we also investigate here the potential hindrances to the use of blockchain technology, to bring those into, say, university environment for gaining access to certificates. We also assess how blockchain solutions impact on the stakeholders and develop a framework for the implementation of blockchain technology for certificate verification systems. So, yes, I hope everybody can see. I get a message who can see the transcript, but I hope everything is good. Everybody can see the slides. So as part of the research, model was developed to determine the suitability of blockchain for certificate verification. So here's an adoption of what is called a BPMN diagram, usually used for business processes. But here we have kind of a decision tree for deciding what blockchain could be used. So if you go down here, the decision tree, I mean, to cut a long story short, you can read then details in the paper. But the point is, do we reach a leaf where, you know, we just see it's not feasible to use a blockchain? Alternatively, if we see we can use a blockchain, for certificate verification, the question is then, do we use a public or a private blockchain? How many institutions are involved in the control, and also what sort of consensus algorithm. So there are several considerations. It's good to have this type of decision tree that makes that you can follow in order to make a more educated decision about what blockchain you would like to land with. So the entire research was motivated by the needs for the verification, a verification system that should be convenient, time-saving, reliable, and cost-effective to the universities and the verifiers. And we also wanted to address that there's a high labor turnover and cost of replacing loss of patronage and revenue. We have possible lawsuits and reputation damage that recruiters suffer from certificate forgery. So it's not just this the case that certificates are hard to get, but also that certificate forgery is often occurring, and this is also a big problem, certainly for the recruiting procedures. And so the idea is that there's a need to hand the certificate ownership over to the graduates, and to save educational institutions reputation damage. So of course, if you have certificate forgery and there's some institution mentioned, and then it turns out, I mean, so somebody recruits in good faith, but then the chosen candidate who gets the job turns out to be completely incompetent. If it isn't discovered that the certificate is a forgery in itself, then of course it reflects badly on the mentioned educational institution. So many problems involved, being very costly, a lot of reputation and trust lost, and so on. So so we followed this case study-based methodology, just like in the previous case. And we had certain research questions, just very quickly. How can blockchain technology enhance the certificate verification systems in university? And there we have sub-questions to establish separations of concerns, and also to deal with research complexity in a better way. So the questions are how to establish the implications of blockchain technology on academic certificate verification systems, how to determine the benchmarks for assessing the benefits of applying blockchain technology for certificate verification systems, and how does the application of blockchain technology for academic certificate verification affect the system stakeholders. So data has been collected on the one hand side from document review. So you typically, in case study-based research, look at the literature, at the theory, and so on. But in addition, you also then conduct semi-structured interviews. So you harvest the state of the art from the literature, and then you have your gap. And for that, you conduct the interviews. So in this case, we had 16 respondents, which is actually quite good for master thesis. So anyone who knows how case study-based research works, you have to collect interviews, do the transcriptions, do the thematic analysis with the coding, make sense out of it. It's very elaborate. So Mercy did a very good job on that, I would say. The 16 respondents were from university verification officers or corresponding officers, employers of labor and graduates verified with knowledge of blockchain. Everything was recorded and then analyzed. I mean, the thematic analysis, the transcripts were thematically analyzed using Arcuda. So we have then here the current system of certificate verification, where we have the graduate who applies for a job. Then we have the verifier who receives the application, requests a certificate. The certificate is then submitted, and a verification request is then sent to the issuing institution, and then they have to look into the records, yeah, which can be a very lengthy procedure, of course, depending on the degree of automation and maturity of organization that you find in the issuing institution. As I said, I mean, this will, for first world listeners, this may sound a little bit like a non-problem, but trust me, in developing third world countries and so on, this is for sure a big issue. So if the records can be found, the feedback comes back, and then in the end, a decision is made. Is the job being offered, or is there a reject to the graduate? Yeah. So you might get an intuition here how well complex things can be. Yeah, certainly if you are not so well organized with the record keeping. So the key findings are that degree certificates are primarily paper-based, at least in developing countries, and stored in physical repositories and verified manually. So you can imagine how cumbersome that is. Being a manual process and characterized by delayed response and delivery, higher administrative cost for universities, high verification fees, and clients' dissatisfaction. And may I say at this point, very often, the only thing that works is to add a little bit of financial lubrication in the verification procedure to get things moving, if you catch my drift. There's possible hindrances to blockchain adoption. So let's say poor IT facilities, lack of digital skills, funds are lacking. There's poor power supply. Say South Africa suffers from load shedding, which means the power is just going off for extended periods of time. Actually, something that now also comes to the first world, certainly to Europe. Load shedding coming from, say, South Africa to Europe, not just being a developing country problem anymore. There's maybe ignorance and resistance to change for adoption. So the blockchain benefits can be assessed by lesser verification time, more accuracy, reliability, lower costs, feedbacks, volume of verification, easy retrieval of certificates, convenient verification. And there's an impact on the stakeholders. So there's assurance to graduate, better decision for recruiters, increased productivity, and the possibility of working remotely, and a reduced need for contact with clients. So yeah, here we have listed the conclusions, the different frameworks for blockchain-based verification systems. So Mercy and Chibuso, they come from Nigeria. So that's why it's a bit Nigeria focused, yeah, where the interviews were conducted. So we have certain recommendations. So it's recommended that the parties are involved, and that's really necessary. Well, to involve the university and the different stakeholders in introducing blockchain systems. You might even have interconnectivity of university systems that requires experts to deal with that. You need common standards for certificates, consultative counseling and collaborations. Best would actually be to have first a pilot project that involves the major stakeholders, kind of in a sandbox before you roll out immediately on a large scale at a university such a blockchain system, where things might get out of hand and fail. You don't want that. So yeah, so this I don't understand now, the diversified income sources. But in any case, you definitely need upskilling and staff retraining in order to cope with the new blockchain situation. And also, of course, universities are governed by laws, its own laws, and maybe even national laws. So those would have to change, say, data privacy and so on regulations, but also on a micro level, say the university laws would have to be adopted. So for future research, we mentioned here that it's good to understand the implications of the adoption of blockchain technology actually better. And further research should facilitate implementation based on this research, the lessons learned, actually moving into some sort of prototyping and addressing how to install and configure the technology. So I think I'm just on time. And I'm not sure if any of my co-authors is present. I'm only 1 minute behind. So if there are any questions. Okay, I think I have to again get out of the screen share so that I can see. Yes. Have you implemented a system you proposed, not necessarily in large scale real implementation, maybe in a lab? If so, what information do you keep in your blockchain transaction? If not, what information should be in transactions in your perspective? Again, this was case study based research, so not design science research. Again, this would be future work, maybe something you want to pick up yourself or anybody else in the audience. So it would for sure be very interesting to do a university-based implementation. We have actually, so Chipusur, the co-author, has been involved in implementing a certificate management system that could be available. So if anyone here is interested in the audience, in maybe trying that, if they're at a university or so, or some educational institution where there's an interest to bring certificates on blockchain for in a verified way. This would be very interesting and something we could try together. So I said before, I'm a recovering professor. I'm actually now I'm a researcher, but I also have my own companies, and would be actually quite interesting, for the implementation which we have already, to find a real case somewhere. So if there's anyone, please reach out to me. Okay, then thank you so much, and I would hand over to the next presenters. Thank you.
Thanks, Alex. I believe Anwar Al-Samani, combining
Yes.
blockchain and semantic technology, the survey. Are you there?
Yes, I am.
Oh, great. And are you able to share your screen?
Yeah.
There you go. Great. Thank you very much.
I think I'm not able to share my screen.
Okay, you should be able to try now.
Sorry. Yes, I am now.
All right, great. Thank you.
Okay, sorry. Okay, I think I have to change my device. Just a minute, please. I'll join from other device.
Okay, I'll elevate that person as well so that you can share your screen.
Hello, everybody. Are we doing okay? It's Dave Gonzalez.
Hello. Hi.
Hello.
I'd like to share my screen, please. Yeah.
Okay.
David, I got it. Yep, I got him.
Okay, cool. Thank you.
Yep. Thanks, Dave. Yep, we're seeing your screen now.
Okay. Hello, my name is Anwar Samani. I am from Swansea University. I'm going to talk today about combining blockchain and semantic technology in a survey way. So I'm going to cover introduction, motivation, survey methodology with the questions, survey overview, and discussions with conclusion, and welcome your questions. So one of the blockchain definition is it's an emerging decentralized technology which has massive potential for data sharing applications between interested entities. And semantic technology, ST, such as ontology and knowledge graphs, are well recognized for formalizing meaning related to data. So what motivates me, I have been for a long time thinking about what can semantic technology do for blockchain technology and what blockchain can do for semantic technology, which lead me to a bigger question, which is what can the combination of both technologies do for the industry? So ST is the efficient querying and modification of data, whereas BCT is used for secure storage and tracking changes. BCT already enabled the safe and fair exchange of digital assets in a decentralized manner. However, its application to information exchange remains largely unexplored. From the beginning of the semantic web, the awareness of the need for trust for data stored in the semantic data pools was strong. So it's missing that trust in the semantic data pools. So we can see some challenges in today's industry, like in the blockchain industry. The data storage problem is not, the data stored in the blockchain is not well supported. And also there is a problem with searching and determining provenance and security. So combining BCT and ST, the symbiotic relationship that support both technology and the potential that can be reached by merging them, as both have an impact on enhancing data with the trust and meaning. So our contribution for this survey is to expose existing relationships between BCT and ST, including technical aspects, rather than focusing solely on theoretical ideas. So we use Scopes as a database, as our database, and we use this expression. Once we apply these expressions, we got 361 papers. So we do the filtration process by removing unrelated papers. Then we do an exclusion criteria. In exclusion criteria and exclusion criteria. In exclusions, when the main focus of the papers are the combination of both technologies. And exclusion criteria, if the main focus is not the combinations, so we remove those papers. Then we finally run out the selection process by reading each paper abstract carefully, because so many papers talking about this combination, but without providing any technical details. So we end up with 29 papers. So we have identified 4 main areas where blockchain and semantic technology are combined. The first and largest one is BCT industry, blockchain itself, and then comes organizations, then supply chains and semantic technology industry with the same percentage. So we formalize 4 questions. First one is, what are the main challenge areas addressed by combining BCT and ST? Second one is, what are the main advantages, disadvantages, and limitation of this combination? And then the third one is, what are the main technical ideas to combine blockchain and semantic technology? Lastly, what is the proposed future research on the combination of BCT and ST? So in order to answer first the question about the main challenges area, we have established main themes and side themes. So as you see, we have 4 areas: a blockchain area, organization, and supply chain, and semantic technology industry. Due to the large information on blockchain industry, we divided it into 3 main areas: data integration, storing and querying, data modeling and standardized information, then others, which include hidden configuration process and creating custom structures. So we establish main themes. First one, interoperability between data sources, which occurs in all areas. And then, for example, for it, it's data on the blockchain need to integrate with other type of data and other technology stack. The second main theme is data storage and retrieval, which occurs in most of the areas, excluding semantic technology. So this main theme has 3 sub-themes: improving blockchain data structure, with search is under blockchain industry, and security sub-theme occurs in supply chains and in organizations. Then we have side themes, the GDPR compliance, general data protections, regulations, which occurs only in the blockchain industry. And recently, there are GDPR knowledge graph that has been integrated with the blockchain to have an audit log of every operation. Then we have the second side theme, which is provenance and traceability under the supply chain. It occurs only in supply chains area. As you may know, one of the major concerns of supply chains is determining the provenance and the source of information. So many supply chain systems currently suffer from low level of readability, scalability, and data accuracy. So blockchain can facilitate ontology to be used for much improved supply chain. The second question, what are the main advantages? We have many advantages. For example, in blockchain industry, interoperability and searchability will be improved. In supply chains, data presentation capability and transparency will be improved as well. And for the third question, what are the main technical ideas to combine blockchain and semantic technology? In a technical perspective, blockchain area is the largest area, so we divide it into storage technology technical perspective. It has file storage and data storage, data indexing, and matching. For file storage, for example, a safe storage and fast reading of files in the process of building a knowledge graph are guaranteed. In data storage, applying the graph chain architecture can create a distributed graph data storage. Also for data indexing, a safe procedure for transforming the word nonlinear matching problem into a privacy receiving word nonlinear matching is created. For example, here we can take technical perspective for semantic technology industry. Storing the expert knowledge in a decentralized blockchain enables the understanding of the model concept. For the last question, what is the proposed future research on the combination of blockchain and semantic technology? All areas needs to be investigated more. For example, in blockchain area, the design of a secure semantic searching scheme under decentralized storage is needed. And in organizations, the support for semantic data retrieval on the blockchain need also to be investigated more. To conclude, main areas, benefit and technical perspective and future work have been identified in our paper for the combination of PCT and ST. Improvement in efficiency, security, and privacy have been also proposed for all areas. So we can say that research into this combination of PCT and ST has only started, and there is a full potential still need to be explored. Here you can see this diagram summarizing our paper. Here you can see the areas, the 4 main areas with indicating the answer for each one of the 4 questions. Thank you for listening. Any question?
Yes, I would have a question.
Go ahead.
If you can hear me. Yes. Have you heard of the OntoChain project?
OntoChain, yes. Yes, I did.
Yes. Okay, very good. Because I'm part of OntoChain. So I was in call 3 with the project, which I will talk about for my PhD student on Wednesday. But yeah, so OntoChain in particular takes a close look at this intersection of semantic web and blockchain technology. So and they're having now the latest well round of projects that are ongoing. So I was curious if maybe that there could be something going on that benefits you.
Yes, it's excellent paper actually. So this is like just a quick survey. I and my supervisor, Prof. Arnold did. And I think we will refer to your paper. I think we selected it.
Okay, wow.
Yeah.
Thank you.
You can refer to our paper and see what we have wrote about it.
I will do so. Yeah, very good.
And I think there's one more question on here for the speaker. Since when were the basic paper to identify the theme collected number of years?
We started our research current paper. It was started from 2000, I think 18.
Great, thanks. Just to try and keep us close to schedule, we're a little 3 minutes over, but I'll transfer over to.
I was afraid I.
Are you done? I'm sorry. Oh, it's
so
okay.
I just skipped some.
Oh no, I appreciate it, and thank you for keeping us on track.
I just opened my new Mac today, so I just use it just to put the background for the conference. Yeah, but
no problem. But thank you, I appreciate it. So we'll move on to our next speaker, Tamara Hughes, standardization efforts for blockchain and energy domain and power grid applications.
Yes, I am.
Great. Let me know if you can share. Okay, I think there you go. Great. Video's coming through. Great.
Okay, I think we're set.
Yep, confirmed. I can see your slides.
All right, great. Thank you.
Oh,
thank you. Yep. Good morning. Oh, sorry.
Go
ahead.
Would you mind swapping? I think it's on the notes side versus the presentation side.
Okay.
On the swap displays. There you go. Thank you.
All right. Good morning. My name is Tamara Hughes, and on behalf of my co-authors, Umit Kali, Murat Kuzlu, Sri Gorsetti, Sambit Mishra, Marco Passetti, Claudio Lima, Farouk Rahimi, and Fuika Nitu, I am presenting our paper standardization efforts for blockchain in energy domain and power grid applications. Today, we'll cover some background. I will introduce the IEEE Standards Association P2418.5 Working Group, cover the 4 task forces comprising the working group, discuss some industry perspectives, and a few of our conclusions. So blockchain is today's most promising technology for power grid applications. But going along with that is standardization. And if anyone was listening into Dr. Soretta's presentation earlier in the Q&A, he described that blockchain is, in his opinion, ready for prime time. So broad commercial scale adoption, but that in some use case scenarios, there's a regulatory element that is involved that may be a barrier, if not a necessary element of helping drive that commercial blockchain adoption. So standardization is an essential process that can help inform the regulatory processes and help advance that adoption. But with that said, standardization development itself presents challenges. If we think about this in the context of the energy domain, and in particular power grid applications, there is a very diverse and complex geopolitical, geographical, regulatory environment that we have to manage. So when you think about developing a standard that is applicable to an industry, a challenge then is defining standards that apply regardless of the underlying regulatory environmental differences. Standards development organizations have been very active, but they have generally been industry agnostic. So ITUT, ISO, other areas of IEEE, for example, the P3203, 3204, and 3205 working groups have been working on blockchain, particularly interoperability standards, but in an industry agnostic manner. So the IEEE 2418.5 Blockchain and Energy Working Group was formed by the Standards Association to focus blockchain standard development efforts on the energy industry. So the working group formed in 2018, if I'm not mistaken, late 2018, early 2019, with the first step of defining an initial reference framework and an initial step of kind of mapping the reference framework with use cases. The central working group activities and coordination, the task forces, are done under the broader auspices of the working group. And it follows a consensus-based approach to revise, refine, iterate, and improve. An agile methodology, if you will. We solicit the input from industry and academia through identifying key use cases and conducting surveys, interviews, as well as the participation of individuals in the broader working group. The task forces, interoperability, smart contracts, use cases, and cybersecurity form the core of the working group. And there's a broad and a necessary collaborative strength of the working group in that synchronization and collaboration with the other IEEE organizations and outside of IEEE itself. So as I mentioned, ISO and ITUT. And an example is the IEEE Blockchain-Enabled Transactive Energy Initiative. The outputs of the working group are technology, vendor, and implementation agnostic, a standards draft document, an updated version of the reference framework, which is the result of that revise, refine, iterate, and improve. I apologize. Let me My slideshow seems to be going on its own. And other dissemination activities, which include publications and presentations such as this one. Again, I mentioned the 4 task forces. Let's take a look at those in a little bit more detail. So the use case task force was not a surprise given the name, was tasked with putting together an inventory of use cases in the power grid / energy domain for which blockchain or DLT technologies could be optimal. In the paper, we discuss a couple of the use cases that were identified: token-based payments and operational flexibility services, but those are only 2 of a broader catalog of scenarios, with an objective of the task force to identify the 20% of use cases that cover 80% of the grid. The cybersecurity task force was to, I apologize. The cybersecurity task force set out evaluating the evolving network attacks on the evolving blockchain technology. So looking at the 51% problem with Bitcoin's network, and looking at the DAO attack on the early Ethereum network, and where smart contracts were the weakness in that case, and how those attacks were evolving as the underlying blockchain technology itself evolved. They identified through that effort security gaps in both the public permissionless blockchains and in private permissioned blockchains, which led to the conclusion that what was missing in a cybersecurity aspect of the existing blockchain cybersecurity research was a framework that could be used to define a use case, evaluate use cases, evaluate the security of any given blockchain technology, as well as potentially help select a blockchain technology for implementation. So they developed that framework, they mapped it to the TCP/IP model, the OSI model, and the smart grid architecture model. And this has been published by the task force in a couple of papers that at least one I know is publicly available. Interoperability. So interoperability is what it, from what the name implies, is looking at how do we adapt, if we need to adapt, any existing standards to facilitate the interoperability across, from traditional grid architecture, if you will, top to bottom, and then through all of the elements of a transaction to ensure seamless and secure processes for accomplishing those transactions. Through their early efforts, they defined a device, syntactic, and semantic component layers within which to frame discussion. And they identified 4 types of device and system interoperability feature sets: device connectivity, which is the physical media, protocol connections, the protocols, the meaning, why is this communication, why is this information being exchanged, why is this protocol being used, and then dynamics, behavior, and conceptual connectivity. So the abstract of how participants, if you will, in a blockchain system and in a transaction might interact, and what their behavior in those interactions might be. Smart contracts is a task force that really sits at the intersection, if you will, of cybersecurity, privacy, regulatory, software development domains, and is tasked with aligning all of those domains and managing the evolution of those domains toward putting together guidance on smart contracts. A couple of findings to date from the Smart Contract Task Force are that there is continued and if not growing research in the integration with control and metering hardware. So smart meters advanced metering infrastructure, and where a smart contract layer or how a smart contract could interact with the physical hardware. As it regards the use of smart contracts in any grid applications, there were very positive results from a local electricity market simulation that relied heavily on smart contracts that was conducted in Southern California. Industry perspectives. So where did the working group get its industry perspectives? I mentioned interacting directly with members of industry and academia. And toward that end, the working group commissioned a survey of energy industry participants, and the responses, we had 82 responses as of October 2022, and the results that we'll take a look at were as a result of August. So 82 survey respondents today, representing a broad group of participants in the energy industry, including energy policy body. The various utility segments are represented, and of course, academia and research and development organizations. Some of the findings, we were also respondents were globally represented, with the bulk being in North America, but participation across the globe. From the survey, within the next 5 years, almost 60% of the respondents indicated they will be implementing a project or a proof of concept utilizing blockchain. All blockchain network types are being considered: public permissionless, public permissioned, private inter-organizations. So think of akin to the financial services, so JP Morgan and others that have a private inter-organization blockchain being used to track financial transactions, and hybrid. But everyone anticipates challenges typical of new or emerging technology development or rollout initiatives. So performance, interoperability, scalability, cybersecurity. Also of note with blockchain is the legal constraints. This ties back somewhat to smart contracts and more broadly the decentralized nature of blockchain, in that if there is a challenge or an issue with a transaction, where is adjudication taking place? What is the jurisdiction, or what jurisdictions apply for that type of an issue? That can inhibit the business acceptance, not the technical or technology team's acceptance or adoption, but the business adoption of blockchain. So just to highlight a couple of our conclusions, to handle the complexity of the energy industry, new regulatory and governance structures are necessary. And this is where standards development can help inform those efforts. And one key observation was a potential disconnect between the research and academic experimentation and what may be more appealing to the private energy industry. So the step between R&D and full commercial adoption and commercialization of an emerging technology. And again, this is where standards can help break down those barriers and help answer some of the questions that are on the commercial side to ensure interoperability, cybersecurity, all of the aspects that the task forces for the IEEE working group are focused on, so that provides some stability and certainty to the business that this is not going to change out from underneath the efforts, or that everybody is looking at the same playbook, so to speak. Thank you, and I appreciate your time. Are there any questions?
There was something in the chat, but I'm not sure that was for us. It's not something I could translate. Okay.
All right, thank you very much.
Thank you for the talk. Next up, believe we have Rizvan. For the, let me just pull it, all these
Yes, I should.
blockchain enabled economic transactions. I'm sorry.
Can you hear me, guys?
Yep. Oh yeah, there's a little bit of an echo. I also hear Carmen. Were you gonna ask a question?
So hang on a second. Just I think that the message that you're referring to was actually for me. It's in Romanian, saying that a friend of mine managed to connect to our Zoom, but inadvertently she might have sent it to the whole group as opposed to only me.
Okay, great. No problem.
Say that I'm connected, so she was she's keen to see what we are up to. So we have my name is Razvan Mihai. I'm leading a group of researchers from the Polytechnic University, but also from we have members from the Berkeley University, University of Groningen, Netherlands. So my experience is I have a 20 plus years experience in the audit and financial industry, having been working with in the Big Four front, starting with Arthur Andersen and then continuing with the KPMG. Our topic for today is to show how we can record economic transaction in a more effective and efficient way using the blockchain technology. And I was really excited to see the opening speech today and to see that this topic has been touched upon by Ramesh, but also by what we say the co-inventor of the blockchain, Scott Stornetta. So I'm keen to get in touch and see how we can move this to the next level. Since we have done our research, we have managed to come from the case study research to actually implementing a prototype. And we were highly advised to run the pre-recorded session where we give you the basic points of our paper, but most importantly, and the things that we are very proud of as of now is to see something really running and how we can ultimately eliminate or reduce and ultimately eliminate the work of accountants and auditor. So to that end, do you mind if you run the video, or should I?
If you can, that'd be great. I didn't have a chance to download them ahead of time, so my apologies. If you're able to do so, that would be very helpful.
Let us see that. If not, we'll.
I'm also going to try and find it as well on my end, but if you guys can, we'll take that minute. It looks like you've got it going here.
When you log into it won't surprise you.
Just give us a second.
Make it 0.
All right, I'm really very excited to talk to you today about how the blockchain technology can help record recurring transactions in a more effective and efficient way. Happy to have worked with an international group of people, the details of whom you can find on the paper. At the bottom of any economic transaction, we have a contract, be it implicit or explicit, whereas the transaction are the building block in any economic relationship. A very important distinction in a transaction is that it has two parts. One is the accrual, and then the second is the payment parts, which we don't often get to make the distinction of. This is coming more handy to the accountants, which are used to making that distinction, but let's show to those not familiar with accounting standards. So the first part of the transaction, the accrual part, relates to recording the rights and obligation that has arisen from a transaction, whereas the second part is the actual settlement through the cash payments. This is the overall architecture of our prototype, which is based upon a asset rental use case where the supplier and the customers interact and record their details of the transaction in the blockchain. A contract can be boiled down to 5 parameters, even though sometimes the number of pages may look intimidated, and those are the parties to the contract, supplier and customer, transaction type, in our case will be a recurring, we're talking about a recurring type of transaction, amount, duration, and of course the terms. That's the prototype control flow. However, as opposed to us going through the theoretical aspects of this diagram, I would like to jump into show you how the prototype works. All right, so we'd like to give you a sneak peek as to how the prototype is working. First, the supplier would need to propose a contract to the customer, and to this end, the supplier needs to go to the proposed contract window. It is worthwhile mentioning that on to the left side of our screen we have the supplier window, whereas onto the right hand side we will have the client window showing the interaction between the two. So let's go with the supplier proposing the contract. Supplier fills in the identification details of the supplier of his own. First detail is the account type. We can select here either an individual or a company. Let's go with the individual type. Supplier name, I'll put myself as a landlord, let's say test 11. Interestingly, the supplier public address gets automatically filled in by the prototype from the MetaMask digital wallet. Let us check that this is the right account, which it is. Next, same information we need to fill in for the customer information, but again, worthwhile mentioning by the supplier. So let's click again, individual type, customer name. I will select here on my friend and co-author to this paper. Public address. Public address is supposed to be received by the supplier prior to filling in this information. So I had it copied to my clipboard. And the last thing is the contract detail. And since this is an asset rental contract, let's call it like this. Type, we have 2 types of contracts, either recurring or one-off type of contracts. As an asset rental contract, we'll select recurring with monthly payment. Let's go for 1 Ether monthly payment, starting on the 7th of November 2022 and ending in 1 year time on the 7th of November 2023. Terms of the contract, let's go for the US civil law terms. Let's say no smoking. And one last thing, it's small pets would be allowed subject to approval by the landlord. I would like to point out that the terms, in the terms part, you can fill in all the necessary details that are required by the law, but we'll stick to these small details just for the purpose of the demo. Then supplier clicks the submit contract. And at this stage, we have a proposed contract by the supplier to the customer. We can view that, we can access the view one, and we'll see all the details that we've already inputted and the pending approval from customer notification. If we move on to the customer side of the screen, we'll see the same information. However, this time around, instead of getting a pending approval from the customer, we will have 2 options here, accept or reject contract. Let's go for the accept scenario. And this will directly trigger the MetaMask digital wallet of the customer to confirm the transaction. I would like to point out at this stage that there is no actually money flow from the customer to the supplier, except for the gas fee necessary to write this contract to the Ethereum blockchain. Let's click confirm to have this contract up and running, and we'll need to wait around 15 to 20 seconds for this to go through. Wow, so here we go, we have an accepted contract. So let us go to accepted to the accepted contract and view. Yeah, so this is what we had installed. Let us go now to the Explorer part to see the details of this contract. So it's contract number 11. We've made various tests. Okay, so we see the contract here. Now let us make the payment to this contract. We now see that we have an accepted contract. So let's go and make a payment. We have the customer pays, let's say 1 Ether. It's the end of the month, or it's just a deposit. Again, it automatically triggers the MetaMask. This time around, in addition to the gas fee, we will obviously need to pay the 1 Ether, which is the monthly payment. So we click confirm. Again, we need to wait like 15 to 20 seconds. I'm always getting anxious at this stage, but oh, here we go. Successful payment. So we close that part. So let's go back to the Explorer. Let's click on the contract 11. So here, in addition to what we have already had, the first line was the initially accepted contract. Now we will also have the payment as such. Let's click on the first line to see the detail. We have the timestamp as to when the contract was created, supplier, customer, public addresses, amount, monthly payment, total amount 12, and left to pay this month is 1 Ether. I would like to point out that this is the accrual part for the month. So we have so the customer has an obligation to pay to the supplier, and this is getting recorded onto the Ethereum blockchain. If we go on to the second line, we see here the actual payment, but again we have the same information: timestamp, customer, supplier, public addresses, but this time around we have the amount 1 Ether, monthly payment 1 year, total amount is 12 because that's the whole amount for the whole year. But this time around we have left to pay for this month 0 because the customer has already paid. So that's it in a nutshell. There is still a lot of work to cover for us, but I think we have enough ground to extract the necessary information in order to significantly reduce the work of account keepers and auditors. A significant part of our research work involved the discovery that automatic recurring payments are not supported natively in a non-custodial manner by the Ethereum blockchain, which means that even though we have managed to automatically record monthly the accrual and side of the transaction, which is the rights and obligations, in order to make a payment, you would need to monthly access your digital wallet. This has triggered the development on a new standard by IEEE, which has been recently approved to start. We have the number on the slide, of which the project of which I'm a member of. In addition to that, I would like to encourage you to take a look at the related papers of ours called Recurring Payments on EVM-based platforms, where we attempt to provide a solution to the recurring payment identified problem. Use cases for our prototype are endless, I would say. We start with the asset rental lease cases, but we can go on with loan payments, utilities, monthly payments, gas, electricity, any subscription-based services, insurance. Very important, even employee salary, taxes, as long as they're recurring and ideally fixed in amount. Future work, we would like to integrate the recurring payment automation into our prototype in order to provide a seamless experience between the supplier and customer. And last but not least, we need to address some of the issues related to the privacy of transactions, as many economic players would like to keep certain details of their transaction private. In a snapshot, our prototype provides readily accessible audit history, tamper-proof and time-stamping of financial information, continuous verification of economic transaction. Again, if I want you to remember anything, is the difference between the accrual and the payment part, which are two distinct parts of a transaction. Ultimately, this would lead to automated execution of the recurring transaction and a significant reduction of work done by auditor and accountants, which will ultimately lead to reduced risk. Last but not least, I'm pointing to the significant discovery, which goes to show that the blockchain, even though it provides a lot of leverage and advantages, has still some certain limitation that we all need to work in order to overcome. Stop sharing. I cannot do it better. All right. So can you hear me?
Yes, we can hear you. Thank you.
Okay, so I got a question related to let me read this out loud. The prototype considers publication blockchain or private blockchain. So I guess the question is, the prototype consider public blockchain or private blockchain? So our prototype is based on Ethereum testnet. We started with the Robston, but since the move from proof of work to proof of stake has taken place in October 2022, we moved on to the testnet called Girly, and we believe that we are on the side of supporting the public blockchain. So this private blockchain, to me, of course, there is a debate on this, but they can be technically shut down at any point in time by those in charge of those, whereas public blockchain are there to stay. The challenge is, how do you make sure to make the information public or not on a public blockchain? And this is given that the economic players may want to may not want to show their commercial details. So this is further work for us, and we believe that there are ways to address this issue using zero knowledge based solution, and that's for us to look into further.
Any other questions for Razvan? Okay, I think that we're just a little bit over time. Thanks everyone for attending this session. There are, I think the metaverse session is still going. If you want to pop over there, And please check out the Whova app for any more sessions that you want to attend. But thank you all to the speakers and for everyone attending.